Good morning, good afternoon, good evening, ladies and gentlemen. This is Odilon Ngu. I'm here with my friend Tehuti, and today we're going to have a quick conversation about a book that I wrote called Intelligent Systems. Well, you can't see it with the background, but this book is a book that attempts to solve the theory of everything, which is the concept that there is some unifying theory that unifies everything and explains how nature evolves and how nature emerged and even how everything interacts with nature. So Tehuti and I have been friends for quite some time, and for the last year or so, we've actually been having a very frequent conversations about just everything, just how nature works, history, historical context, everything. And he's brilliant, obviously. And today we're just going to explore the book, the motivation behind the book, and some of the things that I think that might be groundbreaking or might add to the knowledge base that we already have on the planet. So thank you guys for having us. Tehuti, please take it over.
Yeah, so really, the book was really a fantastic book from my perspective. Just the format alone really was brilliant, because again, I read so many books, academic and scholastic books, and the book really ties into that scholastic academic field. I really feel like that the book has the potential, or just the body of work has the potential to pierce the crowds of the Harvards and the Oxfords, that crowd, because that's really where the book is, and that's what I view the book as, because the body of work is really solid, So yeah, so really intelligence. Let's talk about it. Intelligence. What is intelligence? Let's deal with it.
Yeah, I mean, exactly, right? So, what is intelligence? So basically, this book is a book that I was motivated to write this book because I needed to find my place within nature.
Mm-hmm.
That was the motivation.
Right.
Simple as that. And I was a young child. I've always been very curious. And I've always been very interested in the philosophies and the mathematics. And this question has been something that I've pondered for quite some time, as many of us have. I'm sure you have too. And some of the great scholars of our past, throughout history, have tried to solve this problem, right? And I mean, religious scholars spend their entire lives trying to figure out the solution to how nature emerged and how nature is able to sustain itself over time, right? And so it just so happened that my pursuit of self-understanding, of self-actualization, allowed me to get to the point where I realized that the solution to me is the solution to the problem that all these scholars have tried to solve for thousands of years, right? And all the way to the Paul Dirac's and to the Einsteins, whose goal was to unify systems, unify how all intelligent systems work. And when I say intelligent systems, I'm referring to essentially systems that are intelligent in a sense, like nature is intelligent. Would you say? Right. Go ahead, I'm sorry.
Yes, I agree. Obviously, the intelligence present within nature, you just, again, after you've got the plants and the constant computation, the photosynthesis is 95% efficiency rate. So let's look at the high level of intelligence within nature, and I really feel that, so, but would you say that, so the premise of the book, is the premise here that, or does the concept itself, are we dealing with that there's an intelligent author for everything in the universe? Is that what we're saying here?
So author is, okay, that's an interesting term. I would say more like an algorithm.
Right.
But an algorithm would imply an author, obviously. But the interesting thing about this is that yes, there's an author, but every author has an author too.
Right. That's deep.
So and that was the thing that's been difficult for us as a humanity, as a human race, to try to figure out is, if there is an author, what is the equation?
Right. But what if some could argue, what if this equation is too complicated for the human mind to even comprehend, considering that's what brought the human into existence? And this algorithm is too complicated to even comprehend. Is that a factor?
So I mean, there's an argument to be made that the algorithm might be beyond the dimensions that we currently exist in as a human race. There's an argument to be made there. But the argument that's more interesting is the one that maybe this is not that. Maybe it's not that esoteric. Maybe it is simple, right?
Mm-hmm.
Which is why it's been protected for so long, because it gives the holder of this key, of this algorithm, the ability to recreate a universe.
Right.
Which means that they can also destroy a universe.
Right. You know,
so the implications are,
that's really deep, because what we're basically saying is that if we knew the algorithm, then we could eventually become gods on Earth, essentially become God, because again, that's what created the universe. You see,
mm-hmm.
That's powerful information. Right.
And the argument is this, right? Do we become gods, or do we go back into the godly nature that we innately are?
Right. So he's saying, is the destiny to become that, and that's the destiny, and that's the innate nature. We're really just getting back to the innate nature, as opposed to becoming something that's external but was already within to begin with.
Mm-hmm. Exactly, and an example that we can talk about more detail about the book content later on, but is a simple notion like this: the idea of replicating self, right?
Mm-hmm.
It starts as a zero-dimensional thing. It starts as a thought, right? And this thought is able to transmute in a way,
mm-hmm.
or mathematically, we call it it has homeomorphic properties, where it's able to transition dimensionally mm-hmm. into higher dimensions, to the point where this thought becomes a person.
Right.
It goes through the process and it emerges just like the universe itself.
Right.
Material created from nothing.
Mm-hmm. Right. See, that's one of the concepts that I like when you deal with the material and the immaterial. Mm-hmm. So you're saying that through the immaterial, the material came into being. Right. The fashion of the universe.
Exactly. And I in this book, I describe intelligence to be infinitely finite.
Mm-hmm.
Right? And the finite nature of intelligence is the discrete nature of intelligence.
Right.
And that's what we're talking about. We're talking about the discrete nature of intelligence. Because we can model the discrete nature of intelligence, but we cannot yet we could not yet model the continuous, infinite mm-hmm. aspect of this intelligence.
It's interesting you would say that, infinitely finite. So could you expand more on that for the people that may not be familiar with the term and the concept? I'm sure, I think I've read somewhere that Einstein said the universe was infinitely finite. So could you expand on that and really elaborate for the people?
So infinitely finite is essentially, so I guess we can start with Gödel's incompleteness theorems, mm-hmm. where he talks about the fact that essentially all of the knowledge systems that we have are inherently incomplete.
Right.
None of those knowledge systems are ever going to completely model nature. Mm-hmm. Because they're discretized representations of this infinite intelligence. Right? So when we say infinitely finite, we're saying that there is a duality to intelligence. Mm-hmm. This dichotomy that goes through all intelligent systems that gives them the properties of discreteness and continuousness and continuity. And this is the representation of an infinitely finite system.
So when we talk about nature, when you say that the infinity is manifested in the physical realm, is that even possible, or is the physical realm itself just really a piece or a strand of this? And when you did with string theory itself, we're talking about there's infinite, many different universes, many different possibilities, but this, can it even manifest down here? So is that even possible?
It's a great question. So I think they coexist.
Mm-hmm.
So the discrete nature of intelligence it coexists with the infinite nature of intelligence. Because remember, if you talk about uncertainty principle, there's an infinite possibilities of possibilities.
Mm-hmm.
But at that moment, that's just a possibility that's discrete. That's what exists, depending on what dimension you exist in and how you perceive it. That's what exists at that moment. It's just, it coexists with the infinite aspect of intelligence.
Right. So would you say the human's goal then is to become infinite? What are we meant to tap into the infinity? Like, what is the goal? What is the goal here?
So the question is the goal of the human to become infinite again? Okay, mm-hmm. And that's a good question. So now let's use an analogy of a baby, for example.
Right.
Now let's imagine intelligence is an entity, right? Now, when a baby is born, does a baby have a high level of connection to that infinite intelligence, or a low level?
Well, you could imagine the highest level. I would imagine.
Okay, but the baby was just born. The baby came from 0 dimensions. It came from idea, then it went into 3 dimensions, right?
Mm-hmm.
So would you say that the idea had the highest density of information than the actual discretized baby? Right. Because the baby is just a discretized strand, like you said, of that infinite intelligence that existed within that sperm.
Right. So are we saying that sperm has the infinite intelligence, or is it many, and that's why there's so many sperm that needs to be released?
So essentially, the premise of this is that every single system is governed by that algorithm.
Right.
That governs all systems at the fundamental level.
Right.
That's what we're saying.
So what we're saying is an underlying algorithm that governs all systems, and if we only knew that algorithm, then we can manipulate all systems?
Exactly. And we can optimize all systems to 100% efficiency, which essentially means replicating self.
Right. But, okay, so now with the concept of efficiency, is the human 100% efficient?
So efficiency also comes with its own sort of baggage. Efficiency for what? Is it the utility of efficiency, or efficiency for the universal system of intelligence? Because yes, there is an optimal version that optimizes the universe.
Right.
But if you're talking about utilizing human, then that's a different conversation about the efficiency of the human being utilized for something else.
So if we talk systems, okay, solar system, animal system, human system, to me the sun is the most efficient system, right? And then we're versions of that. Can the human ever reach that 100% efficiency that is the sun itself? Is that even possible? Or should it even be possible?
For a human to reach the efficiency of the sun? I'm not sure if I can answer that question. I'm not sure if we can. I mean,
that to me is the highest level of efficiency. I don't think a human could ever
within our dimension.
Right, within our dimension.
Yes,
within our dimension, yes.
So that.
Just from an energy standpoint, energy input output.
The argument I'll make is that this discrete aspect of intelligence is like a correction.
Mm-hmm.
But it's a built-in correction.
Right.
So in a way, the human is inherently flawed. The human is inherently inefficient.
Right. Okay.
Which is why the human dies.
Right. So death is a climax of inefficiency.
Exactly.
Right.
Which tells me that it's a regression of life. It's a regression of intelligence. Like the human life cycle is actually a regression of intelligence, or in a way moving farther away from that density of the sperm.
Right. So now let me ask you now. Okay, that's deep because I like the concept, life and death. So now reincarnation. Is that a mathematical? Can someone mathematically constitute reincarnation? Does that fit in to this model? Can it be mathematically constituted? Would you say that?
So an argument can be made that after death, this place where they talk in religious, the scholars call it heaven.
Right.
But this is the place of infinite dimensionality, of highest uncertainty, of highest information density. So in a way, death is just going back.
Right.
It's just going back to essentially to the density of that sperm, which is why it's so interesting, because we're talking about 0 dimensions to higher dimensions, right? And it's a tough concept to wrap your head around because it's counterintuitive.
Right.
It's because we've been trained to sort of believe that when you age, you actually gain intelligence because you're actually acquiring knowledge, right?
Right.
But are you acquiring knowledge really, or are you actually regressing, and what you're acquiring is more of a correction to the fact that you cannot actually reach that original dense knowledge efficiently, like a baby can.
So we're saying aging is not actually getting better, but we're getting worse, is what we're saying.
That would be the argument. The argument would be that yes, is that our civilization in a way has been regressing in intelligence.
Right.
So the more discretized our knowledge systems get, which is why we have all these different schools of thoughts, all these concentrations, mathematics, physics, chemistry. The more it becomes discretized, then it's actually a signifier of our regression from the original dense knowledge. Because if you go backwards, right, historically, there's less and less concentrations.
Right. But so now back to what I was saying in the original point. Now the concept of reincarnation is then you die and then you come back to restart the cycle again. But so when you talk about death is the climax of inefficiency, and that dying, that's basically what an inefficient system does. It dies, whereas a 100% efficient system like the sun, there's a continuation. So does reincarnation fall into that? And as an inefficient system tries to become efficient, so it constantly comes back in the cycle and reincarnate. Would you say that fits in?
So there's an argument to be made there, but from a mathematical perspective, I haven't really explored reincarnation from a mathematical perspective. I haven't explored that. I'm going to think about it more, but I definitely, there's definitely what do you call it? Like just like there is emergence from nothingness, the opposite happens, where there is a dissolution when things dissolve into nothingness.
Right.
The same way it came from nothingness is going to go to nothingness.
Right.
So to me, that's the full cycle.
Right.
So if the cycle repeats itself, I can't really speak on that until I think about it more. But That's the full cycle of life, and that duality actually is mathematically represented by the notion of the equality sign.
Right. Okay. There you go. I wanted to tap into that. All right. Yeah. So again, now I know you touch on that now, and obviously the equal sign now. So what is your whole perspective on that? You touch on it being essentially incomplete. Can you elaborate more on that? What is your perspective of the equal sign?
Yes. I think the equal sign is the philosophical representation of finite intelligence, or what I explore in the book, known as spherical intelligence, or spherical dimensions.
Right.
And I can go deep into the mathematics of it, but Poincaré proved already, and other mathematicians already proved that at the fundamental level, all systems are unit squares.
Right.
Right? Go ahead.
So when we're dealing with the equal sign, from my perspective, it's that's equal. It's that's the result almost. Exactly. So 2 + 2 is 4. That's the result. But that's the result as far as how does that tie in then? If we're saying if that's the result of this mathematical problem, this is now the result.
So to me,
isn't that completing the system?
So exactly. So it stabilizes the system.
Right.
And that's what makes it stable within the discrete dimensions. Just like when you blow a bubble,
right?
And the bubble forms a sphere and it floats away. Right. That was water and soap, and now it's discretized into the most fundamental entity. Right. And now it has shape, and now it can be manipulated in higher dimensions.
See, I like the concept. So we go from this 2D plane to this 3-dimensional sphere, right? I like that.
Exactly. And the equal sign topologically, like we had in our previous conversations, it just represents this dichotomy within intelligence, right? This duality of completeness and incompleteness. The notion of infinitely finite. But guess what? The equality symbol is the finite nature of intelligence, and that's all it represents, which is why we've been stuck within this discrete final system. And it's very difficult for us to comprehend the infinity of everything else because we're stuck within that finite sphere of intelligence, that discrete sphere.
Right. But again, like I was mentioning before, as far as the infinity, would you say that we're not supposed to manifest infinity, but we're supposed to chop that up into feasible, manageable aspects, and that's where the equal sign comes in to allow us to chop that up into manageable sections.
Exactly. So the equal sign allows us to stabilize it, essentially, right? To stabilize it. But now it's time for us to now open the next door, because the equal sign was monumental, right? Most of our mathematics today uses the equal sign, right? But now the next school of thought is the infinity symbol.
All right, so now we got to go to the next level now. So we're saying equal sign. This is where we began. Now that's the next level. So now infinity symbol. So now how can that be applied? That's what they're going to ask. How can it be applied? Where do we go from here?
The infinity symbol represents the infinite, complete representation of the infinite dimensions and the finite dimensions. So now we're getting a more complete interpretation of nature. So now we're not saying that two things are equal. We're saying, how does this thing fit within the universality of all systems? Is it optimized to actually be part of nature?
That's powerful.
That's what it represents.
But to get to that level, then, is that kind of human? Obviously, if I say 2 + 2 = 4, that's math that I can write down on a piece of paper. When we get to the level where we're writing infinity now in our equations, is that math that I can just on a piece of paper or do computers need to be involved now because that level of math now is beyond us?
So it's actually much simpler to understand nature from that perspective, because it's complete. So the issue with reduction and discretization, well, it's not an issue, but it's incomplete, is that it dilutes over time.
Right.
It becomes it thins out, and that's why discrete systems die. That's why we die.
Right.
We thin out. We stray away. We evolve farther and farther away from that original density.
Right.
So, and that's why the systems that we use today are inherently inefficient.
Right.
We build cars that you have to refuel.
Right.
Our bodies need food to sustain themselves. But if we live in infinite dimensions, we don't need that. Everything is self-replicating. Everything is infinite.
Right. So are we saying in the module then, would you say that this reality, or this third dimensional reality, is built upon inefficiency? Is that what we're saying?
100%.
That's powerful. That is powerful. So how then the ultimate question, the ultimatum really, how does one then escape this inefficient hand almost that we've been dealt based on the foundation? How does one escape that? Is that even possible?
Yeah, that's a question that I've pondered for quite some time. And I think it goes down to a fundamental change that has to happen with the school of thought at the fundamental level. And this school of thought is the school of thought that actually would give rise to the emergence of mathematics.
Right.
So essentially, we hold mathematics to be the holy grail. Right? But we have to go beyond that now.
Right.
We have to now have a system that gives rise to our mathematics while taking into account that there's an infinite number of other mathematics or math knowledge systems that exist in other dimensions.
Right. So we're saying in order to go to the next level, we have to start bringing down possibilities of other dimensions, including, and we have to start incorporating that into our math, because math is the foundation of our logic, the foundation of our philosophy. So we need to start bringing those systems and start building that math system right now from the other dimensions.
Exactly. The reason why Earth looks the way it looks today is because we use the equal sign. If we had a more complete understanding of nature, the Earth we live on today would not look like this.
Right. So now
go ahead.
So now let me ask you now. Okay, so the equal sign, that's powerful. And you obviously, I'm dabbling into the programming world now. I'm dabbling into the coding world now. And the equal sign is very prevalent within the coding world. And coding, we're making the CPU, we're giving it instructions. So are you saying that even computation itself has to be rewritten?
I mean, Alan Turing proved this already. Even computation itself is finite, and thus it's incomplete.
Right.
And the reason why we use the equal sign with our current computers is because it's stable.
Right.
It creates an arbitrary constraint that allows us to make sense of information.
Right.
Bring it from 0 dimensions to 1 dimension to 2 dimensions, and then now we build our fucking world. We have 3-dimensional objects now. Our mathematics allowed for the existence of our phones.
Right.
But if our mathematics is incomplete, what does that mean? It means all of our systems are incomplete.
Right, that's powerful.
Everything is incomplete.
That's a big statement. Everything is incomplete, but it's a powerful statement, and it's a necessary one. Again, so now let's tap into quantum computing. So are you saying, okay, so if classical computing is incomplete because it's the equal sign and we're using an equal sign prevalent within our programs, but classical computing now, I mean, quantum computing, are you saying are we tapping into that infinite realm that we are speaking of and the inefficient realm by way of quantum computing? Are we tapping into that?
Exactly. I think that's what we're doing. I think with quantum computing, we will have the option to now play with infinite structures.
Right.
Which and these infinite structures, they're interesting because they travel all the way to different dimensions.
Right.
So in a way, they're highways.
Right.
They're roads that are going to help us commute with because they go through all the dimensions.
Right. That's powerful. So when we talk dimensions now, this is again deep. So now when we talk dimensions now, dimensions again, we live in the third dimension. So are you saying that the other dimensions are invisible to us, but are they accessible? And if so, how can this be done?
Great question. So the other dimensions are invisible to us because we're constrained within our discrete system. But we can access infinite intelligence if we have the right philosophy, if we have the right formula, if we have the right knowledge.
Right.
Because this is infinite. It's everywhere. It exists already. Right? Like an example is this. Einstein, Newton, these guys came up with equations, but where did these equations come from?
Right.
There's an infinite amount of equations that exist, bro. It's infinite.
Right.
Equal MC squared. All that did was model energy. That's it. Energy is just one. It's just a little layer of knowledge.
Right. And that's deep because. So now my question to you is now, how do we? If we're saying that we around infinite dimensions and they can be accessed, how does one now recognize infinity? How do we recognize that we're tapping into now higher dimensional knowledge, higher dimensional aspects? How do we recognize it? How is that even recognizable? And how is that recognizable and not just dismissed as that's insane? That's crazy. How do we recognize?
It's imaginary. Right. It's imaginary.
So how do we recognize it? How do we start incorporating that now and putting that into our universe and our reality? How do we recognize high dimensionality?
We have to redefine everything.
Right. So everything has to be redefined. I like that again, because that's right. That's powerful. But what you're saying is it first must begin with the mathematics, and the equal sign essentially needs to be replaced even. Or can it coexist with your system, or does it completely need to be just taken out?
And that's a great question that you just asked. So like I said, there's nothing inherently wrong with the equality sign, the equality symbol. It's just incomplete.
Right.
Because there are times when it does make sense to zoom in.
Right.
Right? But if we're going to build the foundation of our civilization, we're not going to build that with an incomplete equation.
Right.
That foundation is not strong enough, and it's designed to collapse. Death. Right? And I have a hypothesis that that's why civilizations collapse.
Right. Come on. Let's deal with it. Right.
Seriously, that's why they collapse.
They
have the wrong equation. They have the wrong philosophy.
Right. But would you say that it's an inherent destiny for all civilization to one day collapse? Would you say it's mathematical because its formula is wrong, or is it just because that's the nature of reality for nothing to last forever?
It's the nature of reality based on the fact that our entire civilization is built on an incomplete equation. So that becomes the nature of reality. And that's why it is to solve the problem of humanity, we have to go beyond mathematics.
Right.
We have to define what preceded mathematics, what gave birth to mathematics.
Right.
Because like I told you before, to me, mathematics is just an elevator to the infinite dimensions of intelligence.
Right.
That's it. That's all math is. It's an elevator.
Right. But you're saying there's different ways to get there. And that the equal sign, or that there's actually new realms to get to
the equal sign gives us the access to every floor.
Right.
How about that?
That's deep. You know,
and now it's our choice to decide where we want to go.
Right, that's powerful. So now my question for you now then, you know, okay, so now we hear a lot of talk AI. Everyone's talking AI now. Everyone wants AI, machine learning now, deep learning. They're talking about all these things now. So now, right now, we have they call it ANI, artificial narrow intelligence, which you can, you know, it's designed to do one thing and one thing only. So, video game, chess, you know, and self-driving cars. And they also have AGI, artificial general intelligence. So now they want to basically model human intelligence. So now my question to you is now, can human intelligence, in its complexity and in all that it is, reduce to a set of instructions? Is this possible?
And that's a great question also. And I think those are the two opposing schools of thoughts that we've sort of come to the point where we have to pick a side. Right? And that is the notion that intelligence is local to the mind, to the brain.
Mm-hmm. Right.
And that's the prevalent school of thought today, is that it's local to the brain. And my school of thought with intelligent systems is that the brain, like every other system, is emergent.
Right.
But what did it emerge from? And what is it tethered to?
Right.
That allows it to still have this connection, even though this connection is fleeting, even though you lose connection over time, the rope, the tether gets longer.
Right.
It's still connected to that infinite intelligence. How do we do that? How do we define that?
So what we're saying then, it's not that intelligence or consciousness, biological consciousness, or we say intelligence is local to the brain, but we're saying it existed before, and that the brain is really the intermediary between that, but it's not the author.
Exactly.
Right.
Exactly. Right. It's not the author. That's a great way to put it. It's not the author. And that's why I have a bit of an issue with the notion of AI, because I feel as though, yes, you can always have predictive accuracy.
Right.
If you zoom in.
Right.
If you discretize, that's it. But every system that's built today, over time, depreciates and collapses.
Right.
From the mechanical systems to even our biological systems.
Right.
They inherently die.
Right.
And that's the reason.
Right. You know, so that's interesting. So again, from my perspective, I don't think, because if that's the notion that we can just quantify human intelligence as a mere set of instructions, I have to say that what made Einstein do what he did, and Einstein's brain was running, was just a different set of instructions. So I don't think it's possible. I don't think they can actually, because a God doesn't create another God. A God creates something lesser than itself, a human, which within itself is godly, but a human. A God doesn't create another God, so how can we then create another human? As far as the intelligent aspect, AI intelligence.
There's a gradient. There's a gradient of intelligence, and the notion of AGI is more interesting to me, because AGI basically is trying to replicate the universe.
Right.
And to me, that's what's more interesting, because I just see the current AI systems to be like calculators. That's it. They're just calculators. Right. But can they replicate the universe? Can you rebuild the universe in a quantum computer?
Right.
With that model.
Right.
With humans in there, with whatever dimensions in there, whatever you want to describe. Can you do that? And if you cannot do that, then it's not intelligence.
Right. But see, that would, even from the standpoint of how AI or how quantum systems come about, that's actually impossible, because the energy, they're talking about decoherence. So the issue that they're having, they can only have a few hundred qubits in superposition because of the decoherence. So the amount of energy you need to require to even stabilize. So they're saying it's the wiring bottleneck. It's one wire per qubit, right? Mm-hmm. So in order to even have an AI system that can even model the whole universe, the energy that we could produce down here can't even build the system. We can't even build it. There's not enough energy that we can produce down here that can produce that system.
And you know why? Because we're still stuck in the energy realm of Einstein.
Right.
Turing talked about this. Incomputability. There is a threshold.
Right.
If we're dealing with intelligence at a fundamental level, then we're dealing with this thing that comes before energy.
Right.
We're stuck within the energy realm, so we cannot self-replicate within the energy realm. That's why they say the so-called God or whatever exists beyond the 3 dimensions.
Right.
He's all seeing because he literally can replicate it. Right? Or whatever he or she, whatever you want to call this entity, right? But to me, this entity is not it's a philosophy. It exists before mathematics.
Right. And then math is what we use to understand that entity. Right.
Because math is the elevator to it.
Right.
And right now we're on some floor, but we don't know how to get to the highest floor.
Right.
Just the elevator can't do it.
So what we're so the premise of what we're saying here is this isn't the end. There's more here, and the gateway is through math, but the gateway is understanding that the system we have is incomplete with the equal signs. Something else needs to come forth in order to go to the next level.
Exactly. At the fundamental level, the equal sign is incomplete, which we prove in this book, geometrically, topologically. And for us to open the next door for civilization,
right,
to go to the next level, we have to go beyond the equal sign.
That's powerful.
We have to unify everything.
That's powerful, but what if that's too much? What if that's too much for this current timeline right now to go beyond the equal sign? Because the equal sign is so prevalent within all things, what if that's just too much right now? What if? How what's the span, what's the year span where that would become feasible? Where we can go beyond the equal sign?
As soon as we have computation strong enough to deal with really, really, really large entities like the E's and the I's and the Pi's.
Right.
Once we can play with those, we're going to start playing with something that's much, much larger than energy.
That's powerful. And you're saying, and once we get to there, the doorway is infinite. Infinite possibilities awaits us, essentially.
Exactly. And not to get too religious, but before this book, getting there required death.
Right.
And now we're going to have access to that door again.
Right, within life itself.
It's a door. And we have to open it. And I think we just did. But now, what are the implications?
Right. The question is humanity ready to open that door?
I don't know. I can't answer that question. But I think it's time that they know that the door can be opened.
That's powerful. One must know before we can enter. That's powerful.
Mm-hmm. Yeah, man. It's been a journey. That's all I can say. It's been a journey. So
but really, what your book does, and I feel like again, the Harvard and Oxfords, those people those crowds need to take notes of it, because what you've laid down here, this body of work, really is questioning reality and the mathematical system we have, the equal sign and different things that you have, and also we didn't really touch into the formula that would have been good to go into. But it really is a serious.
So we're gonna go into that. We're gonna go into the depth of the mathematics on the next episode. But this episode today was just to introduce the book and sort of give a quick background to the audience if they're interested in knowing like the motivation and stuff like that, which we covered today. But on the next episode, you and I are gonna go into the meat of this book and go into the geometry, because I want to go into the geometry. I want to go into Gödel's theorems. I want to talk about Alan Turing, go into more detail about incomputability. I want to talk about Poincare conjecture. I want to talk about the rectangular peg problem. I want to talk about Grigori-Perelman and the square peg problem. I want to go into the meat of this, and we don't want to overwhelm the audience too soon. So we're going to take it bit by bit, but rest assured that we're going to definitely explore this book a lot deeper.
And there's so much to explore. There's so much, and this brother right here really has a lot to offer, man. And really, the academic world needs to take note now. This next up and coming brother right here, because it's powerful information, and really, I enjoyed it, man. And it was great.
Thank you. Thank you. And I have to say thank you to you too, man, because you're working on your book, and I'm also inspired, and I cannot wait to get your book. And I definitely think that we're going to be collaborating on a few books in the future, because I feel like I think it's our duty to those who know must teach. So I think it's our duty to help others if they want to be helped, to sort of understand or get a perspective that they're not familiar with about nature and how systems work in general. So I'm very excited for the future, and I think it's going to be fun.
Yeah, so that's powerful. So yeah. Hope you guys enjoyed the video. Hope you took some good information. It's all right, people. Thanks for watching.
Thanks for watching. Yeah, we can keep talking, but you can